Section 12-2, really the last section we're going to cover in chapter 12. Zeros are polynomials and their functions. So we're going to use the factor theorem, what we call the factor theorem today. We're going to use the rational zeros theorem. And then the last two things, a little bit. We're going to touch them a little bit, but not really a whole lot. So step one, we're going to use the factor theorem. So the factor theorem, the factor theorem, the polynomial x minus k is a factor of the polynomial f of x if and only if f of k equals 0. So kind of like what we did yesterday, where we looked at that x minus k and then our k value went over into the box, and then we did synthetic division and we evaluated maybe like f of 4 and we put that in that box, and if we got a remainder of 0, that's a good thing, or we found what it was equal to. If in fact that remainder is 0, then we know whatever they told us is a factor is actually going to be a factor. So let's take a look at this one. It says, is x minus 5 a factor of this? And we're going to use synthetic division to do this. So in order to decide if it's a factor or not, the remainder has to be 0 using synthetic division. So we're going to go ahead just like we did yesterday and use synthetic division to look at this. So we've got minus 5, so my k value is 5. And then we've got nothing in front of the x cubed, so we put a 1. Negative 7, why I put a 1 there, I don't know. Negative 7, 13, and negative 15. We draw our line, and now what we're looking for down here in this kind of lower right-hand corner is we're looking for that to be a 0. And if it's a 0, it's a factor. If it's not a 0, then it is not a factor of this. So we drop down the 1. 5 times 1 is 5. Negative 7 plus 5 is negative 2. 5 times negative 2 is negative 10. 13 plus negative 10 is 3. 5 times 3 is 15. Negative 15, so it's 0. So then we say, yes, x minus 5 is a factor. So if you were asked to factor this, the first factor of this would be x minus 5. The second factor of this is going to be like we did yesterday when we wrote that out. We started with x cubed, so we're going to go x squared minus 2x plus 3. Okay. And now we've got it started to be factored. Now, could we factor this a little bit further? And may you be asked later to factor it a little bit further. Yeah, you might be. So this first part we really can't factor. It's x minus 5. The second part, we can factor it using the factor tree. So we've got 3 and negative 2. So negative 3 and 1. So this becomes x minus 3 and x plus 1. And that's your, if they ask you to factor it, that's what you would do and what you would conclude to do if you're going to ask to factor it. This said, is it a factor? The answer would be yes, it's a factor. Because the remainder is 0, if you were asked to factor it further, then that's what you would get for your solution if you were in fact asked to factor it a little bit further. Okay, so here's their explanation. The remainder is 0, so yeah, it's a factor. Okay, so now in this next one, it's saying, okay, is x plus 1 a factor of this? Then it says use synthetic division and the factor theorem. Okay, so we're going to do the same thing. Our k value in this case is negative 1. In order for it to be a factor, we know our remainder is going to have to be 0, so we're going to finish this off. So we've got 3, 2, 3, and 7. Drop down the 3. That's negative 3. That's negative 1. Negative 1 times negative 1 is 1. That's 4. Doesn't look like it's going to work. It's negative 4 and 3, so our remainder is 3. So no, x plus 1 is not a factor for this. And you're done. Again, it has to be 0. The remainder has to be 0. Since the remainder isn't 0, you can't factor it. And at this point, then you are done with the problem. Okay, here's their explanation. Same thing we said. Since it's not a factor, it does not work. Okay. Now, in this case, asked a little bit different. It says factor f of x. Factor f of x equal to 8x cubed plus 70x squared plus 83x minus 105, given that negative 7 is a 0. Okay, since negative 7 is a 0, then we know that x plus 7 is going to be a factor. Okay, so our negative 7 is going to go into here. Remember, it's the opposite of it. So that means that one of our factors, our first factor of this, we know is going to be x plus 7. Okay, now it says factor it. The way we're going to factor it is we're going to do that synthetic division. So we're going to go 8, 70, 83, and negative 105. Draw our line. That's 8. That's negative 56. That's 14. You find a calculator if you need it. So that's, I think, 98. 7 times 14. Negative 7 times 14. That's negative 98. So 83 minus 98 is negative 15. 15 times 7 is 105. Perfect. It is a factor, but they told us it was a factor, so we knew that was going to be 0. But why we had to do that now is now we know the rest of this is going to be 8x squared plus 14x minus 15. Okay, so that's the factored of it. Now we have to go back to factoring to determine if the 8x squared plus 14x plus 15 can be factored further because it's a quadratic. Okay, so remember on the top we took a times c. So 8 times negative 15 goes on the top. That's negative 120. And 14 goes on the bottom. So it's negative, so one's got to be positive and one's got to be negative. 20 times 6. So it'd be 20 times negative 6. But remember, because we multiplied by 8, we have to divide this by 8, and we need to reduce. So this reduces to 1, 2, 3, 4, 5, 4. So 4 goes into 5 times, and so 5 halves. So that would be 5x plus 2. I kind of run out of room here a little bit. I'm not going to put that there. And then if we reduce this one, this would be negative 3/4. So our factor for this, we're going to factor this down. Our first factor is going to be, and I'm going to write it up here because I'm out of room. Our first factor is x plus 7. And then we factored the 8x squared into 2x plus 5. And then the other one was 4x minus 3. And there's the factored form of that. You can use synthetic division to do this. Okay, they give you what the factor is going to be, then you use synthetic division to figure out what your next factor is going to be, and then you go back to factoring quadratics like we've done in the past to factor that. Okay, so let's take a look at how they did it. Same thing we did. There's their factor. They're probably going to just factor it, and that's the answer that we had as well. So you can see that it does work. Okay. Let me double check to see if I even had you do this. Actually, let's just do another example. Sorry, I'm looking up a question over here. Okay, so let's go with 2x cubed. We're not using the rational zeros theorem right now. Let's go 2x cubed minus 3x squared minus 23x plus 12. We're going to be given that 4 is a 0. and we're going to factor this. Okay, so we're going to factor this function given that 4 is a 0. So since 4 is a 0, we know one of the factors of it is x plus 4. Sorry, x minus 4. My bad, because it's got to be the opposite. So our 0 is 4, so our factor is always going to be the opposite, so x minus 4. Because we're going to put a 4 in there, we put this inside of there, and then our factor is going to be the opposite of it. We've talked about that. So then we've got 2, -3, -23, and 12. Now we know we're going to get 0, but we have to figure out what our other factor is. So we're going to bring down the 2. That's 2 times 4 is 8. That gives us 5. That gives us 20. That gives us -3. That gives us -12 and 0. So our second factor is 2, and we started with x cubed, so 2x squared plus 5x minus 3. Okay. At this point, look at your answers for your problems that you do inside of your book, in your assignment today, because this very well may be where they end it and say that's good enough. That's your answer. If not, remember that we take a times c, so that's -6, and we've got a 5. So that's 6 and -1, but we multiplied by 2, so we've got to divide by 2. So this becomes a 3. So our factor in blue here is going to be x minus 4. This is just going to be x plus 3, and this would be 2x minus 1. And that's your complete factor of it. But again, look at your answers on your assignment today. They very well may leave it like that. They very well may take it to the next step. You just make sure you follow along with the steps that they give you. Let's do one more like this, and we're going to switch out of here and go into, let's go into Notebook and do one of these in Notebook. Open. All right, so let's go with x cubed plus 6x squared plus 3x minus 10. We're going to be given a k value that's equal to -5. So anytime they give you a k value or a 0, that's the same thing. So we've got a 0 that's -5. Or so we got it, yeah. Okay, so inside of here, we're going to go -5, and we're going to factor this just like we did before. So we know one of our factors is going to be x plus 5. We have to figure out what the other one would be. So we bring down the 1. It's -5. That's 1. That's -5. That's -2. That's 10. That's 0. Perfect. So that gives us now x squared plus x minus 2. Factor it, -2 and 1. So it'd be 2 and -1. We didn't multiply by anything. So then our factor for this is going to be x plus 5. And then this factors into x plus 2 and x minus 1. And there is your solution. Okay. So that's what your assignment's going to do today. I guess one other thing quick, it's going to ask you about multiplicity. And what multiplicity means is that it's the times that something is a 0. So if I have something like x, my factor is x minus 4, and x minus 3, and x minus 4. My zeros for this are 4, 3, and 4. You notice that 4 happens twice. So since 4 happens twice, we say it has 4 has a multiplicity of 2. And you're going to see that terminology in a couple of your problems today. So if you see that multiplicity words, it's how many times that answer occurs. So 4 occurs twice, so we say it has a multiplicity of 2. 3 would have a multiplicity of 1. And that's what multiplicity means. That takes care of really all we're going to do in chapter 12.